A patient comes into their doctor's office complaining of persistent headaches and dizziness. Her doctor decides to order an MRI scan.
Today, you will see the patient's point of view as they go through an MRI scan and learn how this is all made possible by physics. Leading up to her scan, our patient wonders, how will this help the doctors see what's wrong?
But don't worry, when we are through, you and our patient will have much more knowledge about how physics makes it possible for doctors to treat their patients.
So, it's time for your exam. This is the MRI room. Can you hear the rhythmic noise? This is the sound the scanner makes and is perfectly normal. This is the MRI scanner and its table. Take a look around. Several scans will be made, each one lasting a few minutes. The MRI machine will make loud, rhythmic noises. This is perfectly okay. Now, look in front of you. The operator will place headphones and a head coil over your head.
Magnetic resonance imaging allows us to see inside the human body with great detail by using magnets.
The machine measures the amount of water in different body tissues and is able to generate a detailed image.
Images produced by MRIs are so detailed because our bodies are made up of around 65% water, so we have lots of signals to measure. The water molecule H2O is made up of 2 hydrogen atoms and 1 oxygen atom. If we look at hydrogen in more detail, we can see it has a central nucleus containing a single positive charge called a proton.
So what happens when we close our eyes? Spinning protons in the body come in contact with magnetic waves released by the MRI. Radio frequency currents pulse through you, stimulate protons to spin out of equilibrium, resisting the magnetic field.
Frequency is turned off and protons realign with the magnetic field, releasing energy in a certain amount of time. Proton pairs containing opposing spins cancel each other's forces, leaving the unpaired protons to create a net magnetization vector that aligns to the MRI magnet.
Here on the right, you can see an example of a proton spinning with angular velocity. Here is an equation that could model how exactly the images are produced. The time it takes to realign with the magnetic field and the amount of energy released equals doctors to be able to distinguish between body tissues based on their chemical composition.
The MRI is now complete, and now we know how the images will be created.
Thanks to physics, doctors were able to detect an aneurysm in their patient's brain, which if left untreated would have been fatal. This catch would not have been possible without the use of an MRI.
So let's recap what we just discussed. MRIs can only read positive hydrogen protons of the water molecules in the body. The proton spins along an axis and has a magnetic north and south pole, which allows it to align to an external magnetic field.
Magnetic poles of hydrogen are randomly oriented in the human body. A net magnetization vector aligned to the MRI magnet is created by the unpaired protons. Roughly half of these spin up and half spin down. The opposing spins then cancel each other's forces.
The protons that are used to create the MR signal are the unpaired ones. For example, in a sample of 20 million protons, only 7 are usable.
Thank you for listening, and we hope you now have a better understanding of how the MRI works with relation to physics.
This video is brought to you by the Physics Friends.